everyone. Welcome to Morningstar Math Training course. Today we are studying calculus and introduce so-called polar coordinate system, or sometimes just call it polar system. Actually, we all know that there is already a coordinate system like this. This is a so-called XY coordinate plane or coordinate system. Any point within this coordinate plane can be defined here. For example, this one can be defined as a pair of XY value. Okay, we call X component or Y component. They work together to define the point. And that point also represents this number pairs. Okay, but this coordinate system, although very efficient, but not the best one in some cases. Based on this requirement, we introduce polar coordinate system. We still use this point as an example. We connect this point with the origin point. By making this connection, we have a distance from the origin point with any given point. This is a distance always non-negative, and we name it as r, abbreviated from radius. And we also define the angle of this line segment with x-axis, this one theta. I would say the pair of r and the angle theta also define this point. And naturally, as they are representing the same point, so they have to have some internal translation between the two systems. So what is it? By having this point, we have it as xy value here. It is actually the two distances, this x value here, y value here. And by given r and theta, we know that x equal to r times cosine theta, and y equal to r times of sine theta. So meaning, if we have r and theta, we can get the unique x and y. And vice versa, when we have xy, it is also easy to get r and theta. How? R is easy to get because based on the Pythagorean theorem. So r is just square root of x squared plus y squared. Because in this right triangle, r is just the diagonal, x and y are just the right angles to arms. Okay, but how about theta? When we have xy, we have the ratio of x over y. Right? X over y is just this over this. This is nothing but the tan theta. When we have theta, we can have this equation, and then we can get theta equal to arctan based at y over x. So by this way, from xy, we can get unique r and theta at the same time. Now we know that the two coordinate planes actually can be converted back and forth based on the same point objects. Okay, this is what we learned today. Thank you.